Okay, so the question is question number 3 of 2022 FRQ. For A, I have to find f of 0 and f of 5. The equation for f of 0 is f of 0 equals f of 4 minus integral of 0 to 4 f prime x dx. And 0 to 4 f prime dx is the area of this semicircle, and if we use the basic area equation for semicircle, we can find out that this is 2 pi, but since this is below 0, it is negative 2 pi. And we know that f of 4 is 3, so if we rewrite this, it will be 3 minus negative 2 pi, which is 3 plus 2 pi. And that's going to be f of 0. For f of 5, the equation is going to be f of 4 plus integral 4 to 5 x prime x dx. And we also know that f of 4 is 3. Now, integral 4 to 5 is this area, and we know that the area of this is 1 over 2. It's a basic triangle area equation, so this is going to be 3.5. Okay, so that's A. For B, find the x-coordinates of all points of inflection of the graph of f for 0 to 7. So basically, find the POI. And this is a graph of f of prime, and we know that at x equals 2 and x equals 6, it's since this is a horizontal line, we know that this is the extrema, and that represents that these two points are the points of inflection. And so since f prime x has the graph of f has a point of inflection at x equals 2 and x equals 6, because f changes sign at those points. C is, let g be the function defined by g x equals x fx minus x on what intervals, if any, is g decreasing for 0 to 7. Show an answer that lead to your answer. So g prime x equals f prime x minus 1, and g should be lesser than 0 because it's decreasing, which also means that f prime is bigger than 1. I mean, 1 is bigger than f of prime. So if we look at the graph, this is 1, so we make a line over here, and we can see that at x equals 5 and at x equals 7, all of the graphs are lesser than 1. So these are the interval that g of x and gx is decreasing. So gx is decreasing on x at 0 between these intervals, because g of x is lesser than 0 on those intervals. For D, it is for the function g defined in part C, find the absolute minimum value on the interval 0 to 7, justify your answer. So since g x equals fx minus x, and this is continuous, absolute minimum at endpoint, the absolute minimum will be at the endpoint or the critical point, and we can do this by candidates test, and we will use x equals 0, x equals 5, and x equals 7 to see which one has the lowest value. And if you make a graph x and g of x, gx 0, 5, 7, from the first question we know that for x the value was 3 plus 2 pi minus 0, because we're using 0 as candidate, will be 3 plus 2 pi. And then for 5, it was f of 5 was 3.5, so 3.5 minus 5 will be negative 1.5. For 7, it's 3 plus integral of 4 to 7 dx minus 7, and integral of 4 to 7 is the area of here, and if we make a line right there, we can find out that this triangle has an area of 2, and this area is 1.5, which means that the area should be plus 3.5 minus 7, so negative 0.5. So we know the values, and we can easily find the lowest one, which is negative 1.5. So the absolute minimum is negative 1.5 at x equals 5.